Good afternoon, everybody. My name is Alessandro Perilli. Thanks for coming. So today, we're going to talk a little bit about why private clouds fail. Okay. So before I start, I need to clarify one thing. I just joined the company, Red Hat, 3 weeks ago. Before joining Red Hat, I was a Gartner analyst. I used to lead the research in Gartner for Technical Professional Division. And in 3 years at Gartner, I interacted and helped over 1,000 large enterprise organizations in Fortune 500 group, Global 2000 group. So part of the content that you will see here refer to research that I did myself in Gartner and some of the research that I did with my former colleagues in Gartner, okay? So what we think about when we use the word cloud usually is a simple infrastructure that is always available, possibly cheap, or with the impression that it's cheap. Self-service, standardized, fully automated, which depends on standardization, elastic, which is a fantastic word, right? This concept of the workloads that scale out, scale back in, whether it's no more necessary to have all the resources that they need, based on a pay-per-use model or a consumption-based model in general, infrastructure level-wise, scalable without any sort of limitation, and then with minimal friction in terms of consumption of the cloud, which means fundamentally that once you have the account access, you can log in into the cloud infrastructure, you just go and provision, or you go through the APIs and go and provision, right? This is minimal friction that I'm talking about. So in other words, when we think about the word cloud, we're thinking about this. It's time to do a little reality check and admit that the private cloud actually looks more like this, right? So let me be a little more specific, but not that much. When a public cloud, or the cloud in general, is apparently simple, for an enterprise organization that needs to build it, is actually very complex. It's very expensive. It is self-service, no question about that. The private cloud is as self-service as a public cloud, but everything else is completely different, completely. It's not standardized. In best cases, it's standardized just at the infrastructure level, but not in terms of service catalog offering, so the application that you offer to your cloud consumer within the organization. These applications that you offer through the service catalog are all but elastic, are absolutely not elastic, and we will talk about that. There is no chargeback or showback capacity in most of the cases in a private cloud because very often it's not a high priority of enterprise organizations. They need to solve other problems before that. There is always a constraint in terms of capacity, and hence the need to do capacity management in a very sophisticated way when most of the enterprise organizations usually just go through an Excel spreadsheet. And there is a very intense, I would say, need for process governance, meaning approval workflows, resource reclamation, enforcement of lease time, which are necessary for a cloud that is supposed to go in production. So if we exclude self-service, the enterprise cloud almost always is exactly the opposite of what we expect to find in a cloud infrastructure, okay, in a cloud platform. Why? What is the problem that we have today? Let's start with complex and expensive, or I could say sophisticated and complex and expensive. What you see here is the reference architecture template that Gartner for Technical Professionals uses and enforces in its documents and its research. And it's the one that Gartner clients refer to when they try to build a private cloud, okay? You see that there is an underlying infrastructure layer, physical infrastructure, hypervisor serving virtual machines, and there is the virtual machine management layer. And then there is a delta, a yellow delta, that is made of a number of management layers on top of it. Some of them are very familiar and associated with the concept of cloud, like self-service provisioning portal, the backend service catalog, the orchestration engine. In others that are new into the concept of the cloud, it makes sense in a production cloud, hence the very mature private cloud, okay? All these components together, or at least some of them, put on top of a virtual infrastructure, turn a virtual infrastructure into a private cloud. And these components can be sold all together as a bundle or an engineered solution by a number of vendors on the market, including Red Hat, okay? And this is what Gartner calls Cloud Management Platform, CMP. Other analysis firms, other vendors call it in different way. The point is that just having a virtualization layer or a minimal resource management layer, which is represented by this virtual infrastructure management component on top of the hypervisor, is not sufficient to have a cloud, to have a private cloud. There's much more that is needed to have a private cloud, because the moment you build a cloud that goes in production, you need to have a number of process governance capabilities. You need to have configuration and change management. You need to manage the life cycle of the entire application from the provisioning to the retirement. You need to be sure that the resources allocated for each specific catalog object that is running inside the virtual machines and the private cloud is not consuming resources forever, but as soon as the project that is supporting ends, the virtual machines associated to the project gets retired, okay? So it's the concept of resource reclamation. A number of those capabilities are incredibly important in a production cloud. Now, if you don't believe Gartner, and don't believe me in this case, let's call for a second opinion. And let's call cloud chief engineer of eBay. So this is long, boring. I don't want to get through all of it, right? I don't want to distract you too much. But there is a central point. I wonder if I can. I will probably do something wrong right now. Well, I don't risk to compromise the presentation. But the point, the central point says, these include infrastructure. So it talks specifically about OpenStack and says an OpenStack installation doesn't make a cloud, okay? There are additional components that are necessary. These include infrastructure onboarding, bootstrapping, remediation, config management, patching, packing, and so on. So very much in line with the diagram that you saw from Gartner in the previous slide. To run a cloud, to have a production cloud, you need a number of upper-level management capabilities that OpenStack doesn't provide. OpenStack of an alternative resource management layer doesn't provide. Yes. Okay, perfect. Thank you very much. I need to learn how to use it. Okay, on the other side. Okay, now I know how to use it. So by itself, OpenStack is not enough to run a cloud. It's necessary to have an upper-level management stack that we call Cloud Management Platform, right? The problem with this is that to put in place all the components that are in the upper-level Cloud Management Platform layer I just described, there is a lot of time and resources and effort that is necessary. This is another diagram that comes from Gartner, okay? This is a maturity model. I don't pretend that you read all the text in the small boxes. The key point here is that there are 5 phases you go through, from the simplest one to the most sophisticated one, where you have all the components of the previous reference architecture template in place. And depending on each of these phases, you can accomplish a certain number of goals for specific use cases and business cases, okay? So the most basic kind of cloud that you can build with a minimal set of upper-level cloud management capabilities, so a very, very basic CMP, allows you, or at least this is Gartner recommendation, to address one specific use case, which is dev and test, okay? A simple dev and test cloud, which is the overwhelming majority of successful implementation of the cloud in the world today. Almost every enterprise that builds a private cloud is successful just in the dev and test use case. Very few are into production, okay? The ones that are into production, not the traditional banks, the traditional insurance company, traditional healthcare, and so on, but are technology providers that highly specialize their cloud. So this means that most of the customers worldwide are in phase 1 and are slowly moving towards phase 2. where you start to implement additional components of the CMP diagram that you saw in the previous slide. To get from phase 1 to phase 2 and the others, sometimes it takes years. Okay? It may take 6 months, 1 year to finish the first phase, and before you get into second phase, you're fully mature for second phase, it may take a few years. So it means that while it's true that you need most of the components in the CMP diagram that you saw at the beginning of the presentation, it's also true that this is incredibly complex to accomplish. It requires much more time than what the vendors would expect. Second problem, partially standardized and barely automated. Okay? The cloud we say should be highly standardized. It's not. The private cloud is not. It should be fully automated. It's not. Why is not? Here we go. Because it's easier said than done. This is another study that Gartner did, okay? Interviewing a number of early adopters that went very deep in terms of implementing orchestration technologies and trying to obtain the most out of cloud management platforms through scripting, through automation technologies on top of existing CMPs, by using CMP's native capabilities, and so on. What they discover is that there is a progression, an exponential curve of complexity, the red one, as you try to automate the provisioning, not the entire life cycle of an application, just the provisioning of an application, the more components of an application you want to automate in terms of provisioning, which means that when we talk about infrastructure as a service cloud, we're basically talking about a fully or in theory, we're talking about a fully automated cloud where the compute, the storage, the network resources are automated in real time, fully automated fashion, okay? But then on top of that container, which can be a virtual machine, you need to deploy in equally automated fashion all the other components, which means the guest operating system, the middleware, the application, depending on what kind of tier of your application you are trying to deliver, okay? What they discover is that the more pieces you want to automate in terms of provisioning in a fully automated way, the harder it becomes to accomplish the task with the existing cloud management platform solution on the market, for a number of reasons. First of all, because compared to a public cloud infrastructure, the enterprise infrastructure is made of many different legacy systems at the infrastructure level. Okay? And you need to have a CMP, a cloud management platform, and the underlying resource management layers that can integrate with all these different components. You don't have the luxury that public cloud providers have to create a data center from scratch and design from scratch a fully standardized system. You need to deal with the system that already exists, that are in place. This is the first challenge. The second challenge is that even if you manage to have a standardized or a semi-standardized underlying infrastructure, you need to deal with the complexity of deploying the application layer on top of the container, which is the virtual machine in our case. And that is even more complicated because when we design the deployment, when we execute the deployment of an application in the physical world, we usually go through a process that is not automated, is not standardized, is very hard to repeat, and almost always not documented properly, which means that to replicate the provisioning of the same application in the physical world, almost never we do exactly the same steps. The moment you want to deploy the same application, so convert an application in the physical world into an application that is standardized for the service catalog in the private cloud, you need to go through one first step, which is understanding exactly what are the steps for provisioning, and convert those steps for provisioning into an automation workflow. And the automation workflow will be executed by the orchestration engine that you saw in the diagram in the previous slide. This operation alone, the conversion from the physical world into the service catalog object, takes an average of 6 weeks minimum, okay, for an average complexity of catalog object with limited dependencies on other components that exist in the enterprise. Which means that in 1 year, you have chances, realistic chances, probably, to convert no more than 10 applications. It's an enormous effort. And if you think about the number of applications that a traditional enterprise has in its application portfolio, we're talking in the number of the thousands, hundreds of thousands in most cases. So you are basically usually coming to the project with an expectation to convert your application portfolio of thousands of applications into catalog object, when in reality you can do that probably for no more than 10 per year. And most of them anyway will be too complex and will fail in the conversion phase. Right. So there is only this much that is provided out of the box by existing tools on the market, and the effort to fully automate the provisioning of an application sometimes doesn't return, in most cases doesn't return on the investment. The best return on the investment, which is a balance between the complexity and the provisioning time that you can cut when you automate a part of the provisioning process, is exactly where the green curve and the red curve mix together, crosses. Okay? So it goes beyond the infrastructure as a service level and it reach up to platform as a service level. And this is so true that, in fact, a large majority of organizations in the world don't go for full automation of the entire stack in terms of provisioning. The overwhelming majority, the mainstream of enterprises that go through the automation of a private cloud usually stay at the operating system layer, what we improperly call infrastructure as a service. Why improperly? Because as you can see in the curve, there are a number of tiers, a number of layers at the infrastructure and application level that you would expect to automate in full, but actually are too complex to automate. So for example, there are a lot of organizations that don't automate the provisioning of the storage resources, but need to do that in a manual fashion. Same for networking, which is incredibly complex. So when we say infrastructure as a service in the context of a private cloud, in most cases, we are really talking about compute as a service. Rest of the things are manual provisioning, okay? Manual change of configuration, manual decommissioning, right? Only few early adopters in the world at this point fully automate to the point of the platform as a service layer, and no more than that. So fully standardized, not so much. Fully automated, absolutely not in a private cloud context. So very different from the public cloud. What else? Elasticity. This is the most beautiful topic ever. I love to talk about this, okay? So in a perfect world, which doesn't exist, what you would have is a fully scalable, infinitely scalable infrastructure that serves a number of workloads that are elastic. Elasticity means that these workloads can scale out. It means a lot of things, but fundamentally means that these workloads can scale out, scale back in, depending on what is the demand for the workload, okay, in terms of traffic and in terms of computational power. The problem is that to design an application, or better, to scale out a workload, any sort of workload, you need two things. You need the underlying infrastructure and the cloud management platform software that is able to understand when it's time to scale out and put in place through automation the additional instances, the host, pieces, replica, copy of the same application, but then you need to have the application intelligence to understand whether there are additional instances of itself and can parallelize the workload. If you don't do that, you're simply providing copy of the same application. There is not much value. There is no scale-out model at all. So in other words, when you design a cloud application, a cloud-native application, a cloud-aware application, what you're actually doing, or what you should do, is not just having a cloud management platform that can support the scale-out model, but you should have applications that are re-engineered to scale out. This is another Gartner paper, research document, that describes what are the architectural principles on top of there that you should have in an application that can scale out. And the most important one, of course, is parallelization. I mean, all of them are important, but parallelization is the one that is the most important in the concept of scale out we're talking about right now. Okay? Now, question for you. How many applications in a traditional enterprise application portfolio do you think are designed in that way? Somebody suggests 0, and I'm going to shake his hand later on. But very, sorry? It's very few, very, very few, right? Right. There are very few projects that start today or are starting or will start tomorrow that start to apply these principles. And there are a number of challenges that are not just the actual execution, the changing the way you design the application. It's also a matter of culture. You need to train your application development team to think in that way. They need to learn how to design application in a new model. And that's why at Amazon AWS conferences, for example, when there is a Netflix session, there is 1 million people that want to attend. Because application developers need to understand how to design scale-out application, and Netflix represents a benchmark in this, okay? Sometimes it's very hard to change the culture within the organization in a way that applications start to be designed in this way. Enterprise organization, when I was at Gartner, came back to me and say, hey, we follow your recommendation, which was first thing first, you need to develop an evangelization program so you teach your developers how to design application in that way. And their answer coming back to me was, well, we tried. It's incredibly hard. It takes years to accomplish this task, okay? So we all believe in a future of scale-out application, but the reality is that enterprises take a long, long, long time to get there. And what we have today is 1, 2, 3 experimental projects or 1, 2, 3 pilot programs that go in production where you can really apply and get the most out of the scale-out architecture. And this is an important point to keep in mind for later on. Okay. In most cases, as I said previously, these private clouds don't even have showback or chargeback capabilities for one simple reason, not because it's not important, but because there are much higher priorities, which are trying to figure out the orchestration, the provisioning in an orchestrated fashion of the catalog objects. So they don't even reach the point where they need to figure out, okay, now that we fully understood how to automate the application provisioning a life cycle, how can we measure the consumption of resources? In most cases, it doesn't happen. And there are issues in terms of capacity, okay? It's absolutely not true, of course, that when you build a private cloud, you can provide the same kind of perception of infinite scalability. Scalability, it's just not possible. You have limitations that are dictated by the procurement strategy. There is only this amount of new hardware or software licenses that you can buy per year. And if you are not very careful and very skilled in how you project the growth of your cloud in terms of resource consumption, you may miss the boat, you may miss the opportunity to procure enough hardware resources, enough software licenses for your cloud. Almost always, there is a situation in a private cloud where resources are not enough for the demand, if the private cloud is highly successful, okay? Right, and so there is a need, going back for a second, there is significant need for one of those layers that you saw in the reference architecture template at the beginning, which is the capacity management tier. And then there is a massive need for process governance. In a private cloud, in a production cloud, there's not a single enterprise that I know or ever heard in my 3 years at Gartner that ever say to me, oh yes, we're going for a fully unrestricted model. We give access to our consumer, cloud consumer, dev, IT operation people, line of business staff, and they just can provision as much as they want in production. So it's not going to happen. It works in a dev and test cloud because that is not production cloud. But in a production cloud, it's absolutely not happening. Okay? There is a need for process governance. There is a need for an approval workflow. There is a need to verify what is the request, if the request can be satisfied, what is the budget associated with that. And so there is an approval workflow that must be executed. And after the execution of this approval workflow, once the application gets exactly be provisioned, there must be a system that says, okay, this application, this catalog object, runs for a certain number of days, which is the least time that is associated to it. And at the end of the least time, when the least time expires, there must be an automated system, hopefully, or partially automated, that say, okay, this application is not allowed to run anymore. It needs to be removed because the resources allocated for this specific application need to be used for other applications, for other workloads, okay, for other virtual machines. So there is a need for process governance that public cloud providers almost never offer because it's not their interest and there is not their maturity level, they're not their core business. All right, so what we can do. Best thing we can do, there are a number of things we can do. The first one is that we stay away from a private cloud, okay? So no private cloud at all. And given that I'm still in my trial period with Red Hat, I'm probably fired. So no, I'm not going to suggest this. And not because I care about my job, but because there is an actual value in private clouds. I mean, I care about my job, but there is real value in private clouds. These are two different clients interviewed as part of the study that you saw before with the orchestration curve that describe what they obtain from a private cloud. The first one is a client that implemented an infrastructure as a service cloud. The second one is a platform as a service cloud, okay? There is value in terms of agility, IT agility, in terms of quality, assuming that you can standardize and fully automate the provisioning of a catalog object. And there is a need for certain security level that you simply cannot obtain when you upload your mission critical or your workloads in general to a public cloud. It's simply not possible, right? So there is value in private clouds. Let's not say that just because of the complexity, we go away from a private cloud implementation. Actually makes sense to do that. But must be done in a certain way. First of all, we need to reset the expectations, okay? We must be fully aware of the limitations I just described so far at a very superficial level. But certainly those are the big rocks. As first things first. The second thing, we need to realize, and this is the most important point that I want to bring home, we must realize that there is a certain level of maturity that you have when you start your journey into the private cloud or in general in cloud implementation. And there is only this much that you can evolve after 1 year, 1 year and a half, 2 years into the project, okay? So when you are approached by a cloud management platform vendor that is trying to sell you a bundle, a CMP with 12 different management models in it, you may question the value of that solution. Because in most cases, or better, in all cases, to my experience, you're not going to use pretty much any of those models except 1 or 2. But you're paying for all of them, and you are supposed to deploy all of them in your infrastructure, okay? So the existing bundle of CMPs that exist on the market, provided by a number of cloud management platform vendors, is usually overkill and, of course, overpriced according to that. You need to realize that when you begin your cloud journey, you need a just enough solution and no more than that. And you buy according to that. As a continuation of that, right, you should not expect to fully automate the entire application provisioning, which is a goal for pretty much all the customers I had always an interaction with. You should realize that the actual provisioning of the entire application stack is very hard to achieve, and it's probably few years away. So according to that, you need to be pragmatic, you need to be focused, and you need to think about what is the use case where you return on the investment as soon as possible, which is a dev and test cloud. Again, the only cloud that is successful across the organizations in the world that try to build a private cloud so far, in a large majority of cases. And then, if you really want to introduce scale-out architecture, and this is another very important point, you need to do that in a meaningful way, which means that this idea, this notion that I heard way too many times from way too many vendors, that to implementing a solution like OpenStack for scale-out application implies that everything you have in your IT needs to go away because that is the new world and the old world must be thrown away is absolutely false, okay? It is alienating for enterprise customers, is absolutely not realistic to achieve, it's quite frankly foolish, okay? There are different ways to implement scale-out applications or scale-out tiers of an application without giving away what you have done with an application architecture that is scale-up, actually, in the years, which is what I'm calling in this presentation a multi-tier cloud. So let me try to clarify this. First of all, and this is the part where I try to sell you something, not sure, but trying to explain. First of all, Red Hat has a solution for private cloud computing, okay? Actually, it's hybrid in terms of supporting also a number of diversity outside the corporate boundaries. But let's focus for the context of this presentation on the private part. So where this is a Gartner reference architecture template that we mentioned so far in the entire presentation, this is the corresponding architecture that we have here. Very simple, okay? So you see that the cloud fabric, which is made by the physical infrastructure, the hypervisor serving virtual machines, and the enablement layer for a cloud fabric, which I call in different ways during this presentation. I call resource management layer, I call virtual machine management layer, and so on, is actually provided by 3 different products: RevM, OpenStack, our distribution of OpenStack, and OpenShift. And then on top of that, there is a unification engine, okay, that provides a certain number of upper-level management capabilities that Gartner recommend to have in a CMP, which is provided by CloudForms. Okay? Now, these components that you see here are components that allow you to build the multi-tier cloud that I mentioned in the previous slide, and allow you to introduce scale-out architecture at the pace that is comfortable for an enterprise, which is this. Okay? So let's say that you start, as I said before, with an application, a multi-tier line of business application that has all scale-out components, all scale-up tiers. The web, the backend database, the middleware, the web front end. All of them are designed in the traditional way. All of them can go into the RevM bucket. And you are basically doing a cloud that is based on virtualization. Okay? Let's call cloud 1.0. When you are ready as an enterprise to start experimenting, to start learning, to evolving your application architecture, and you start to put in place some scale-out architecture design, you're basically not changing, not throwing away your entire application, all the tiers of your application, but you're probably changing just one, which is the web front end. You create a new web front end that follows the scale-out model, and that replaces with a switch the old web front end model that was a scale-up. And the moment you do this, you can deploy the new model into this new bucket, which could be OpenStack or could be OpenShift. So in other words, what I'm saying is that compared to the message that you heard so far from the industry and the companies that gravitate around the OpenStack world, there is no such a thing as OpenStack is one cloud and virtualization is another cloud and they are completely separated. Absolutely not. They can be and they should be part of the same cloud that address different needs as tools to solve different problems. The trick is that you need to rely on a unification engine, a management single pane of glass that can understand and manage and deploy and retire the different tiers of an application that you deploy inside the scale-up tier or inside the scale-out tier. And it doesn't matter if you decide, because that is a strategic decision, if you decide to deploy the scale-out tier of your application inside an OpenStack cloud, an OpenStack fabric, or an OpenShift fabric. Cloud Forms in our solution is able to control all of them and keep them together in a logical container, which is the catalog object, which is the only thing that you need to manage as a single entity. Okay? Now, the additional thing that we do, and we intend to do more and more, you will see more and more news from us about this, is that Cloud Forms, compared to this competing cloud management platform that are 12 different models bundled together, is going to take a different approach. It's going to take a modular approach, which means that rather than try to provide all the components together in the reference architecture template and give you everything, which you don't need, as we said, because at the beginning of the cloud journey, you have limited maturity, okay? We're going to provide just enough set of capabilities in Cloud Forms, okay? The minimum that is necessary for you to stand up a cloud and put process governance on top of the fabric enablement that you see below there. For any additional capability, for all the things that are necessary in specific industries, we're going to rely in a massive way on partners. We're going to rely on ISV that work with us and that we certify to provide management models and value added on top of our platform. Let me make one specific example. Cloud Forms is going to provide the just enough capabilities to run a cloud that makes sense without overkill for the large majority of the customers that are looking for a CMP, for a cloud management platform. Let's say that there is one of these customers is operating in the financial market, okay? And compared to the average kind of client that needs to build a private cloud, he needs to have advanced, very sophisticated capacity management functionalities, okay? Rather than try to build those functionalities right into the product and try to sell those functionalities to everybody, even the ones that don't need them, and so create a solution that is overpriced for a large majority of customers, we are relying on partners that can build an advanced capacity management model on top of our platform and provide value to the customers that really need that specific capability. In this way, depending on what is the maturity level that you have just the just enough capability for Cloud Forms, and then as long as you mature in your journey to the cloud, you add management models on top. Some of them will be provided by Red Hat, others will be provided by certified partners. Okay? And we believe this is a better way to approach a private cloud and avoid the mistakes that large enterprises did in the last few years, and that those studies that you saw in presentation capture. All right, questions?
What do you have people you're working already with to build modules? You got examples of those?
We're not ready to announce anything right now, especially because I've been in the company for just 3 weeks, so I would say stupid things. But other than that, stay tuned, because I believe we have some news coming in the next month or so. Other questions? Nothing? Okay, question for you. How many of you already have a private cloud implementation in production? Okay. What the others are doing? Do you have Dev and Test Cloud? Just one? Others are planning a cloud? Okay. How many of you think that all the management models in the reference architecture template are an overkill for their needs? Nobody? Do you think you need all those components from day one? No answer. Very sorry. All right.
I think the most interesting thing you said about is forget application deployment.
I didn't say that. I say application deployment in fully automated fashion is something that is very hard to achieve, right? There is an enormous value in automating a portion of that deployment but there is only this much that you can fully automate because of technical constraints, because of silos organization, because of cultural issues. So when you are approached by any vendor, including us, to try to suggest, well, we have all the components to fully automate the entire application stack, it's very hard to actually make it work.
I guess it's like if you've got 1,000 applications, how often do you actually deploy an instance?
And this is a very good, another good question. I saw many enterprise customers that wanted to convert an existing application in the physical world into a service catalog and went through this massive migration process that lasted for 2 weeks or 3 weeks or 1 month and a half, 2 months in the most complex cases, and ask them, wait a minute, but how many times are you going to redeploy this application through the self-service provisioning portal? Well, just one. Okay, that is not exactly the purpose of the cloud. But it's very common expectation that enterprise customers have when they try to approach the private cloud, when they try to design for the private cloud. That's why I'm saying that it's very important that you set the expectation low, you try to be pragmatic in the components that you need. You need just enough cloud management platform and no more than that. Question? Right. This one. Right. It's not in the sense that they are equal, of course. One is an enablement for an infrastructure as a service, the other is an enablement for a platform as a service. But in the context of the discussion I had, what I wanted to clarify is that both of them are enablement for cloud fabrics or cloud infrastructure, if you like. So the bare minimum that is necessary to create cloud resource pools and to create orchestration components and capabilities and instrumentation, but that both lack the upper level management capabilities that I described in a CMP and that are going to be provided by cloud forms. Okay? In the sense they are equal. Right? No, because they do exactly the same thing. And you see, in fact, that they are based on two different virtualization engines. One is KVM and the other is Docker. So depending, it's not just the choice of how much you want to automate in terms of provisioning, how much you want to abstract in the catalog object that you present to your cloud consumer, which can be a developer, can be an IT administrator, it can be a line of business manager, and so on. It's also in terms of the density that you want to reach. If you want to have a higher density, you probably want to go for Docker. And there's nothing that prevents you to mix and match these components, actually. So you could have Docker inside the KVM virtual machines. But for the sake of simplicity, I didn't go through all the different use cases. Other questions? Nothing? OK. Oh, too early. Go. I'm not sure I understand the question. So you want to know more about the evangelization program, right? Yeah. Right. So what is the question again? Well, this is what Gartner says, right? This is what Gartner says. They say, and the paper is actually very complex. This is captured just a little part of it somewhere, if I can find it. Okay. And these are just some of the architectural principles. I don't necessarily agree with everything that Gartner says, and there may be different models. But yes, fundamentally, there are principles that must be respected to design scale-out application. So at the very least, you want to educate your customers about, your developers about a number of things. One of them is, what are the principles that are necessary to design scale-out applications, which can be this. Second, what is a cloud, which is surprisingly a topic that very few ones understand, exactly because there is this massive confusion about what is a cloud, what is not a cloud, okay? I also heard things like the enterprise cloud is not a cloud, so let's stop calling it a cloud. And then you want to educate, this is another part that very often enterprises tend to forget. You need to educate them about what is your cloud, what component do you have in a cloud that they can leverage. Right, that's exactly right. The The reason why this model, this maturity model, okay. This maturity model suggests to start from the dev and test scenario is exactly the one to familiarize with the concept the cloud implies, right? So automation, definition of standardization of the tiers at the application level. If you don't start with dev and test and you try to go straight into production in building a private cloud, almost always you will fail, because you will underestimate the level of complexity that is necessary, the time that is necessary to put those components in place and do the migration of the application, transformation of the application into catalog objects, and the cost, which is another point that is very significant. Okay. The cost to deploy and customize and integrate all the components that you have in the reference architecture template with all the pieces that you have in the enterprise system that already exist beyond the cloud is enormous. Number 1 and 2 issues for all the enterprise customers I have ever discussed private cloud with in these 3 years before joining Red Hat were customization of the user interfaces for different consumers that are going to interact with the cloud, and the integration with existing components of the enterprise architecture. Not this one, the one that already exists, the enterprise IT, the legacy enterprise IT. So yes, it's trying to automate the provisioning of catalog objects inside the sandbox, which is the dev and test cloud. It's way easier because the number of integration points that you have is minimal compared to doing the same stuff in a production cloud. Other questions? Sure? Okay, thank you very much.